Welcome to Section 10 of PLC Programming from Scratch. Now we are going to start talking about communications, and unfortunately this is one topic on which we are going to barely scratch the tip of the iceberg. There are so many different possibilities and protocols out there for communications. There are things like Modbus, DeviceNet, ControlNet, Delta V, SCADA, Wonderware, Ethernet, Serial, and that's just to name a few. When we look at a panel like the one on the screen now, you see 4 different PLCs all in the same panel, all running the same system. On a simple project, you'll have one PLC running a system talking to one HMI, and that's all there is to it. Realistically, you can run one cable between the PLC and the HMI, and that's all the communication you might need. And that single cable is called a serial cable or a serial connection. And there are generic serial cables and there are proprietary serial cables. But in the end, it's a very closed network. It's something that's not generally able to be expanded to include other devices or other protocols. It's just a simple PLC to HMI communication system. But on a larger project, you might have 4 or more PLCs, and those might be controlling different aspects of a project, different sides of a project, or in some cases you'll have what's called redundancy. Redundancy means you'll have 2 PLCs or more that are actually there to run the exact same thing. One PLC will be doing all of the work, and the other will be standing by waiting for the first to fail. If the first fails or loses contact or anything goes wrong, the second PLC will instantly take over and prevent the process from being interrupted on account of the failure of a PLC. Depending on the complexity of a project, depending on how many external devices and systems and networks will be talking to the PLC, the controls designer may decide that instead of using a serial connection, it might be better to use an Ethernet connection or some hybrid thereof. Ethernet is generally the preferred means of communication for most industrial control systems. That allows all kinds of different devices to meet on a common protocol and exchange information universally. So when you want to be able to sit in a control room, look at one computer, and monitor 20 or 30 different controllers from several different manufacturers running different types of programs, Ethernet is really going to have to be the backbone of that communication system. Even if you have a hybrid setup where there are some serial communications for certain devices, they're still going to have to be adapted up to a switch or an OPC server, and that information is still going to have to fall onto an Ethernet at some point. So to distinguish a little bit between serial and Ethernet communications, Ethernet is a lot more standardized and it's a lot friendlier for talking to other systems. However, there's something to be said for those serial connections as well. If network security is a big issue, if there's a fear of some hacker in his living room across the world being able to access your system and change the way that it runs, then serial communication offers a level of safety that Ethernet generally doesn't. Since the serial communication systems generally aren't accessible from the internet, they're a lot safer when security is a high concern. Also, since these serial connections generally don't depend on a switch, they're a little bit more dependable because there's one less component in the mix that can fail and bring your system down. So let's look at some of the tools available for setting up our network communications. Assuming we're going to be programming with Allen Bradley, the primary tool that they give us to establish communication across the network is RS-Links. When we open RS-Links, we get this very vacant window with a few tools across the top. And when we look at RS-Who, any configured network drivers we have appear on the left, and we can click on those to see what devices are present on the right. And if we need to add a network driver, we come back up to that toolbar and click Configure Drivers. And here we have a list of various serial and Ethernet communication protocols that we can insert into our RSLinx environment. This software also gives us options of taking Allen Bradley PLCs and publishing their tags on DDE and OPC protocols, which I won't get into in any depth, but what that allows us to do is use other types of devices that aren't part of the Allen Bradley platform to receive tags and write tags back to the PLCs. So if we need to export data instantaneously into Excel, we can use DDE for that. If we need to use a non-standard HMI that really doesn't have a protocol built in for the particular Allen Bradley PLC we're using, we can configure an OPC server, and chances are that HMI can be made to communicate with the PLC by means of that server. When we look at this RSWho window, it should be very familiar. When we were in our RSLogix 500 environment and we go up to Comms, System Comms, what appears, although the window looks a little different, is actually just a view of what's going on inside of RSLinx. So even though we're not in the RSLinx application right now, RSLogix is looking to RSLinx to know what kind of network is available and what devices are present. And just as we have this type of configuration window in RSLogix, when we go back to FactoryTalk, the development environment for our HMIs, we come down here to an RSLinx Enterprise link, and when we go into Communication Setup, sure enough, to the right, we see the same drivers, and if we cancel out of there and go into Communications, we see the same thing. Now this isn't the standard RSLinx, this actually has an RSLinx Enterprise built into itself, but that's a limited functionality version of the same software. So RSLinx is really the go-to piece of program when you're setting up communications using Allen Bradley hardware. So in the end, what kind of communications are you going to use? Are you going to use serial, Ethernet, some mix between the two? That is all going to really depend on the needs of your project. But the considerations are how many devices are going to be communicating, over what distance are those devices going to be communicating, will we need network access to those devices, do they need to be in different places around the world, do we have a host control system that's going to be monitoring those devices. If we're designing a water filtration system for a trailer park in Indiana, which is one of my favorite examples, this thing's going to sit in a shed out on some vacant property that nobody's ever going to look at. Nobody probably needs to talk to it or know what's going on with it. An operator's going to pass by there 2 or 3 times a week to check and make sure nothing's blowing up. And serial communication is probably the absolute best way to go for this system. However, if we're in a petroleum refinery, then every single piece of equipment in those 4 walls is going to be monitored by a host control system. Operators of that system will be able to monitor it from home by logging into a website which has a process overview. They will probably have call boxes which will notify their cell phones of any critical alarms to the system. And you'll most likely have several PLCs which are even exchanging data between themselves to know when they have permission to run certain cycles based on what's happening elsewhere in the plant's overall process. So communication can become very, very complicated. The good news is, as a PLC programmer, you're generally not going to have to program the entire plant. You'll have to program one PLC at a time, and it'll have a very specific range of what it needs to read, what it needs to write, who it needs to talk to. Once you're set up on an Ethernet communication platform, there's really not much else that has to be done in the PLC program. External devices such as HMIs and host control systems will read the information out that they need and write the information in that they want. So there's not really any additional configuration and programming required in the PLC program or within RS links or anything like that. So as complicated as it can be, think of it like the internet. You take your computer and you plug in the Ethernet cable, or you turn on the wireless modem, and you're connected to the most complex network of computers in the world. And how much configuration did you really have to do? You're reading and you're writing and you're exchanging all kinds of information all the time, but it really didn't take a lot of effort on your part. All you really had to do was put your computer onto that network. You had to be responsible for configuring your own device, and everything else was able to interact with it because it was all on a common protocol. So that is really what PLC communications boils down to. You're either using serial or you're using Ethernet or some derivative thereof. Communications can be a little different every single time. There's really not a specific formula to use. There's not a single course that you can take to learn everything you'll need to know about communications. The more you know about Windows networking, IP addresses, serial communications, the better equipped you'll be. But there's always a new industrial protocol. There's always a new type of host control system. There's always going to be a customer that wants a different kind of HMI than what you've ever programmed before. So really, once you understand the concepts, you're going to have to keep learning new applications and new manifestations of those same protocols over and over again. It's a perpetual learning curve. So don't be intimidated by it. Understand the basics and be aware that you're always going to have to learn something new when it comes to communications.